As promised during the break, as I was making sure the frame relay was set up, because you can't have successful layer 3 without successful layer 2. So I just checked our frame maps, everything's good there. That's not shown on the screen, but I do show the pings going from router 1 to our 2 spokes, and I pinged from spoke to hub as well. Just quickly again, each router serial 0/1/0 interface is on the 172.12.123.0/24 subnet, and the router's number is going to be the 4th octet. I never really like to just say exactly what I said at the end of the last video, because it reminds me of all the reality shows, especially Hell's Kitchen. They do that. They set something up, they go to 2 minutes of commercial, and then they spend 30 seconds showing you exactly what you just saw, just in case you forgot it already. So let's dive right in. Let's go ahead and get EIGRP configured on router 1. And the first thing we got to keep in mind here is with router EIGRP, you have to name an autonomous system or use something called a virtual instance name, which we're not concerned with right now. We're sticking strictly with the AS number. You'll also note there is no CR there, so we got to put something. And once you put that number in there, you're good to go. And 2.12.123.0, and I'm going to stop right there, because we got 2 things I want to quickly discuss with you. The first one is that first statement, no auto. You see this so often in EIGRP configs that a lot of people think it's a default. It's not a default. The actual opposite is the default with EIGRP. Even though EIGRP is no longer Cisco proprietary, it does still run auto summarization by default. I'm going to have a full lab strictly on auto summarization later in this part of the course. So we're definitely coming back to that. I just want to remind you right now, though, that auto summarization is on by default with EIGRP. Now with the network command, 172.12.123.0, and let's go ahead and look at our options from here. We've got wildcard bits that we expect. And note that this command is legal by itself. I strongly recommend, and your network admins are going to recommend, and Cisco recommends, you do use the wildcard bits. But for your exam, I would definitely keep in mind that it is not illegal to use the network command just with the network number. So I'm just going to go ahead and use 000255. Is that right? Is that right for the wildcard if I want all interfaces that have 172.12 and 123 as the first 3 octets? And then after that, I don't care. Is that the right wildcard mask to use? Yes, it is. Your wildcard mask is kind of an inverse subnet mask. So we've got our wildcard bits in. We've got no auto summarization, and we're good there. So let's go ahead to routers 2 and 3. I'm using a slightly different setup. We moved into some new digs, and thanks to all of you for purchasing my courses and making it possible. Those of you who stole them, shame on you. So we've got an adjacency up pretty quickly there, and I raised the font as high as I can here, and occasionally we're going to have a message go off screen. But you can see dual. There's our routing algorithm for EIGRP. It's a neighbor change, EIGRP IP version 4, AS100. Even mentions the neighbor 172.12.123.1, tells you the interface, and then is up new adjacency. So we're good there. Not sure if I have that turned on here on this router, but we'll see. And just as quickly, dual neighbor change. Now you notice I didn't have to use a neighbor command on our hub router, router 1. With OSPF, I would have to do that to get the ball rolling with the adjacencies, but I don't need to use that on router 1. So we trust, but we do what? We trust, but we always verify our configs, or verify what we see on the screen, actually. And since we didn't see them on R1, although I know we've got them, we're going to run this anyway. Very important command, show IP EIGRP neighbor. And right now, the only values we're really concerned with are the addresses of our neighbors, and the hold time's pretty important, but also note this uptime. I love this, because as I tell people, especially those of you who are really new to networking, it's not just working with the equipment, it's working with the people. And sometimes the people are a lot harder to work with than the equipment is. And we have to play detective once in a while. And you go in, it's like, oh no, I don't know what the problem is, but these adjacencies have been up for 17 hours or 17 days or whatever they tell you. Well, if you run show IP EIGRP neighbor, you can see how long that's actually been up. You might not want to run it right in front of them. It might offend them. But show IP EIGRP neighbor, again, what we're concerned with right now, the address of the neighbors, the interface, the hold time, which should be ticking up by now. Yep, it already went up once. And our uptime continues to increment. Now, let me ask you this. Do we have any EIGRP routes right now? If I run show IP route EIGRP, what am I going to see? First off, you're going to see a huge code table. And that, I believe, is relatively new. When you used to run show IP route and then a filter like EIGRP or OSPF or a specific network number, you didn't get the full table. But you do now, because I actually edited that out of my book because, you were seeing the same code table 300 times. But the important thing is right now, we have no EIGRP routes, even though we're using the EIGRP command. And you're at the CCNP level, so you know the reason is that those routes are all connected. So we don't have anything to see as far as EIGRP goes. So let's go ahead and create some of those. What we're going to do is go out to routers 2 and 3 and add a loopback. Loopbacks are one of your best friends when it comes to home lab work, because you can create as many as you like, except of course what I did because I was talking. Let's try 2 there. Address. You guys thought I just invented a new command. Sometimes I like to do that. So let's wait and see. We'll go ahead and exit out of there. So we've got our loopback on 2. And we've got our 2 loopbacks 2 and 3. Now, I can already hear someone saying, okay, you put loopback 2 on this one and you put loopback 3 on this one. Where did you get those numbers? I just pulled them out of my head or wherever you want to get them from. But what I like to do whenever a lab allows, and of course the only time it wouldn't allow it sometimes is maybe in an IE lab, is number the loopback to match the router. And if I put multiple loopbacks on 2, I'll start calling them interface loopback 22 and interface loopback 222. It's just an organizational tool, but it's a good habit to get into for practice. Now, of course, I need to go ahead and enable these interfaces with EIGRP in order to advertise them. So, what mask would I use if I simply want to advertise the 3333 network or interface IP address, and that's it? I want that one single address and nothing else. Well, I'm going to put all 3s there, and I'm going to put all 0s right here. Now, and that's it. So the key, of course, here is pingability. And now, when I go up to the hub router, which is router 1, am I going to be able to ping the spokes on routers 2 and 3? Let's take a look. First, I'll run show IP route EIGRP, and we see 2 routes that we expect to see sitting right there. And of course, they have D for the code. It's not E, but you knew that. It's D for EIGRP. We did that because people ask that every once in a while. Where's the E in there? I believe EGP, and I don't see it on this one, so that's cool too. But anyway, the exterior gateway protocol, EGP, actually came along first. So that, of course, got the E, so when they came to EIGRP, they just seemingly moved 1 letter back. It also stands for dual, if you want to put it that way. Not officially, but it's a good way to remember dual. So we've got a couple of EIGRP internal routes. We've got an AD of 90. We expect that, and we're going to be talking about internal and external routes throughout this part of the course if you're a little rusty on that. And here's a metric, and that's not exactly hops, right? It's not exactly RIP metric of 3 or something like that. But we also see where those ads came from and the update time since the update and the interface involved. So serial 0/1. So let's go ahead and ping. Here's the thing. And I'm going to go ahead and ping these and then give you a little data lecture. I know it's real easy to just look at that and say, oh, okay, I've got 2220, I can ping that. Take the 5 seconds to go ahead and ping it, because every once in a while, and especially as your labs get more complex, you may see a situation where you've got a route in the routing table, but when you try to ping a destination on that network, you can't do it. And there could be different reasons for that. Maybe you're using an older protocol like RIP that converges very slowly, or it simply could be that the packet is getting to the destination, but it doesn't know how to get back. Again, that's not something you're going to see terribly often in a 3-router network. But again, as your practice networks get more complex, you are going to see that kind of situation. It's an excellent habit to get into. So let's take a look then. What about our spokes? Can 2 ping 3 and can 3 ping 2? It doesn't look good, especially when you've got a couple of ping packets dying there. And okay, so success rate is 0%. That's bad. That's really bad, actually. So let's take a look at show IP route EIGRP, and you can see the reason we're not getting pings over to 3333 is router 2 doesn't even have any idea how to get that started. It's like, hey, what do you want from me? I don't have a route for it. If we do show IP route, there's no match in there, and we go up here, there's nothing there. There's no gateway of last resort. So what about router 3? Can it ping 2222? Doesn't look good. You can lose that first packet once in a while and it's okay, and then you'll see 4 exclamation points, and then after that you should get 5. You can lose a packet once in a while, but not 5 of them. That's really bad. So what I would do at this point is just see, can I ping router 1? Can I ping 172.12.123.1? Let's just make sure I can do that. And I can, so it's not a problem with packets leaving the local router for 172.12.123.1, but we do have a problem when it comes to 2222. Let's try EIGRP. And you can see there's no route here. There's nothing here that begins to match that, so the packets just aren't going out anywhere. Let me show you a quick debug. And you can see we get a lot of information from here immediately. We're getting all kinds of, falses in there, that kind of thing. But the key word here is unroutable. I thought I got a UL in there. There we go. So a lot of stuff going on, and you also see some destinations for 224.00.10. We know that one. We've got that one burned into our little memory chips, right? 224.00.10. That's our EIGRP destination network, our multicast network for our hellos and that kind of thing. So that all looks okay, but what we don't like is the word unroutable. That is never a good word, and we're trying to send packets to 2222, and it's unroutable. So again, this is debug IP packet. It can be filtered down, but I warn you about this in every course. You can't practice debugs in a production network, period, but you definitely can't practice this one, because this is just a little teeny lab with 3 routers and a few EIGRP packets, and you see the sheer amount of information we got just on that. So we've got a problem here. Why isn't 2 getting the route to router 3's loopback, and why isn't 3 getting the route to router 2's loopback when obviously router 1, the hub router, is getting them both? Quite a conundrum. So we will solve that conundrum at the beginning of the very next video. See you there.